All right, so we're talking about something called multiplicity. And then ultimately we're going to be using that to graph polynomials. Graphing polynomials is going to be a 2-day lesson. Today you're really getting the meat and potatoes of how to do it. Tomorrow, all we're going to do is we're going to, basically today, I'm going to take a step out, and that step is factoring. I'm just going to do that for you today, just so you can focus on how to graph. Tomorrow I'm going to make you start from the very beginning and make it factor yourself. And the only reason I'm doing that is because it takes so long, and I want you guys to get distracted from the graphing thing that we're going to talk about. So we're going to talk about graphing polynomials, basically, but before we do it, we have to talk about this thing called multiplicity. So that's where we're going to start off at. So let me calibrate my pen, and we shall begin. All right, ready? Here we go. Oh, I didn't want all that to be up there. Go ahead and copy it. I'll just leave it sitting. So this is the only factoring you're going to see for today, but we'll pick it up again tomorrow. If I ask you guys to find the roots, you guys notice set the y value equals 0, set each factor equal to 0, and then solve. Now you'll notice that because I had two factors that were identical, I end up with two roots that are identical, right? And whenever you have two roots that are identical, we say that that root has a multiplicity, okay? So in this case, it has a multiplicity of 2 because it's repeated twice. It can be repeated more than twice. Now, why does this matter? Well, it affects the graph, and you'll see why in a little bit. But whenever a root is repeated, however many times it's repeated actually has an effect on the graph of the polynomial. And that's what our objective really is for today, is to get you guys to be able to graph polynomials. So we need to talk about this first. It's a pretty short and sweet fact. So that's what multiplicity is. Now, how can you tell when a root has a multiplicity? Well, you can. Today, it sounds obvious, right? Because you're like, well, when you see it twice, right? But the thing is that we're not going to really be looking at these really to identify it. You'll be looking up here. So if you see the factor twice, or it could be written like this. Do you guys see that? That means twice also. So we're really going to be looking at exponents today. So that's how you can tell what the multiplicity of that root is going to be, is by looking at the power. Okay? All right. So let's go ahead and see what the effect is of multiplicity on a graph. So how does multiplicity affect a graph? Okay, so what I'm going to do is I'm going to make a polynomial here. This is a factor, right? And the root that goes with that would be 1, right? And I'm going to give that factor a multiplicity of 2. So it's like x minus 1 times x minus 1, right? And then I'm going to make the same thing over here, but this time I'm going to give it a multiplicity of 3. And what we're going to do is we're going to graph both of these and kind of see what the difference in the graphs are and why. And it has everything to do with that exponent or that multiplicity, okay? So let's do it. I think we start with 3, then we go down to 2, 1, 0, -1. All right. So we're going to figure out what the y values are here to get our graph. So I'm going to plug in 3. So if I plug in 3, 3 take away 1 is 2, and 2 to the second power is 4. And we're just going to repeat that process all the way down. So I did, yeah, I picked them carefully. If I pick the wrong points, you'll miss the point I'm trying to make. Yes. Pun wasn't intended, but it was noted. All right. So what I want you guys to notice here is, what do you notice about these y values? There's a symmetry to them, right? What else about them? They're all positive. Now that's the one I really want to focus on. Why are these positive? In fact, I'm going to make a bolder statement. I'm going to say no matter what, they're always going to be positive. Why?
Because
Because you're squaring it, right? What? A triangle?
Yes,
Pascal's triangle? That's it. That's our extra credits. It looks like this, yeah. Yeah, it does look like this. So anyway, so what I want you guys to notice is that when the power out here is even, your y values will always have the same sign. Okay? Now that's going to have an effect when we look at the graph. Let me show you the graph. Let's graph it real quick. So 3, 4, 2, 1, 1, 0, 0, 1, negative 1. Okay, so here's what I want you guys to notice, is that we started here, right? And it was going down, 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 and then what happened here? It started going up. It wasn't allowed to go down here because what's down here is negative y values, right? But it can't be negative. So what happens whenever your power is an even number is that right when it gets to that root, it bounces off and goes right back where it came from because it won't change its sign. Does that make sense? So there it is. Let's write that little, I'll write that conclusion a little bit. Let's go over here and see what happens whenever it's an odd power. Maybe. So this time I'm going to plug in my numbers, but it's going to be cubed. So 3 take away 1 is 2, and 2 to the third power is 8. Plug it in again. 2 take away 1 is 1, cubed is 1, etc. Now if I plug in 0, 0 take away 1 is negative 1. And that one, when you cube it, is still negative 1. And whenever you plug in negative 1, you get negative 2, which cubed gives you negative 8. So notice that unlike the one with an even power, when you have an odd power, when you have an odd multiplicity, the y values can what? Yeah, or we could say they can change their signs, right? Now let's look at the graph of this one really quick and see what that means for the graph. So I'm going to go over 3, 1, up 8, down 8. So we're going to plot the point 3, 8, 2, 1, 1, 0, 0, negative 1, negative 1, negative 8. So for this one, it was going down, down, down. What happened when it got to its root? It went ahead and crossed the barrier into the negatives, right? And so that's your takeaway here, is that when your multiplicity or your power is even, it's going to bounce off the x-axis at that root. When your multiplicity or power is odd, it will go through the root at that point.
We can kind of remember how we did the report square chart with the positive coefficient and stuff like that, because you can tell like the shape of the graph.
You're right. Good connection. I like that. Good point. All right. That's exactly correct. So I'm gonna write those as statements down here at the bottom because this won't make sense on your notes, you know, by next week if you don't summarize the point there. It's there if you want to double check your work. So here we go. When the multiplicity or power is even, the graph will bounce off the root. And when it's odd, it will go through. Okay, guys, so that's multiplicity, right? So multiplicity is how many times a root or factor is repeated. You can tell what the multiplicity is by looking at the power of the factor. And what it does, it tells us something about the graph. It tells us where the graph bounces off the x-axis or where it crosses or goes through the x-axis. And we're going to be using that fact today to do some graphing. So like I said, today is our first day of graphing. Tomorrow's going to be a repeat of today. The only difference with tomorrow is I'm going to make you do all the work of actually having a factor, but today I'm going to do the factoring for you. You're welcome. All right, so let's begin. I want to make sure I pick a good example to start with here. So example 1. We're going to graph the following polynomial. Now I want to warn you guys, I'm going to make this seem like it takes a really long time, but it doesn't once you get the idea. Like I could probably do one of these problems in about 15 seconds. But I'm going to make it seem long because for you guys, there's a lot of things that go on in my head when I do that 15 seconds. So I'm going to write those things down. That's what makes it take so long. So take good notes. And then with practice, you guys can get it to be 15 seconds too. It's really not that bad. Now, the first step is not fast, but it will be today. And the first step is to factor. But you don't have to do that today. I told you I'm going to do the factoring for you. So the first thing you want to do when you're trying to graph a polynomial is you want to try to factor it. Okay? So I'm just going to tell you what the answer is here. I believe it would be -1/6 x plus 3 squared, x plus 2, x minus 2. So I've went through the trouble of factoring it already, and there it is. All right, so after you factor, what you're going to do is you're going to sure. Factor, what you're going to do is you're going to find your roots. And you're going to do that by doing the zero product property thing. So you take every factor that has an x in it and you set it equal to 0. So I'm going to do x plus 3 equals 0. I'm going to do x plus 2 equals 0. And I'm going to do x minus 2 equals 0. And we're going to solve for x. And those are going to be my roots. So we'll go ahead and box those. And like I said, remember I told you guys I could do this in 15 seconds? Yeah. That's because whenever I'm doing this in my head, you don't really need to write this out. I mean, I don't know about you guys, but I just look at it, it's like, okay, -3, -2, +2. You just need to look at it. It's right there. You don't have to write that out, right? But on your notes, you want it there at least once, right? Okay, so there's that. You want to identify roots. Now this is a factor also, but I'm not going to set that equal to 0 because there's no x there. But if you ever have an x out here, you want to set that equal to 0 as well, okay? All right, so let's go ahead and continue. All right. The next thing is we're going to identify the multiplicity for each root. Yes.
I know you're about to go through it, but since there's an exponent over the x plus 3, wouldn't that be?
That's the one. Yeah, you're on point. All right. So step 3 is you want to identify the multiplicity of each root. So let's take a look at -3. Now, how many times is that root going to be repeated? Twice, because you can see. So just for the sake of your notes, you might want to circle this and draw a little arrow down here like that to show us that that root is repeated twice. Okay? How about this root? How many times is that root repeated? It's not repeated at all, right? So we'll go ahead and just put a 1 there. We'll put a 1 there, and we'll draw our little arrow just so we remember where that came from when we look at our notes later. What about the last one? What's the multiplicity? 1. Okay, so the last two are 1. The first one is 2. Now, would you say this is an even multiplicity or an odd multiplicity here?
Even.
That's an even multiplicity, and this is a odd, right? And what did we say about even and odds?
So why is
The ones that were even bounce off of the root. The ones that were odd go through the root. So in this case, we're going to say the graph will bounce at x equals -3. Since the multiplicity was even, the graph is going to bounce at the root x equals -3. What's it going to do at the root x equals -2? It's going to go through the x-axis at the root x equals -2. What's it going to do at this one? It's going to go through also because it's also odd. So at the root x equals 2, it's going to go through the x-axis. That's a positive 2. And once again, you know, I could tell this all. I'm writing just for notes, but you guys catch you do all that just mentally, like at the snap of a finger? -3, bounce, -2, through, 2, through. I mean, you don't need to write all that, right? But it's nice to be able to see it on paper at first. So there's a lot of details here, but what we're trying to do is graph. And so all we're trying to do is find out parts of this function that we've learned so much about polynomials just by looking at this equation. Now, what can we figure out about this graph? What does it look like? Well, we know what its roots are. We know where it bounces. We know where it goes through. We're going to look at 2 more things in order to get our graph, okay? The first thing we're going to look at is we're going to look at the y-intercept. Now, I don't know if you guys remember how to do this or not, so I'll just tell you, but to find your y-intercept, you plug 0 in for x. But you'll see after I show you the work, it doesn't have to be that hard, okay? So the original problem was 1/6 x to the 4th. Was it minus?
Yes.
Tell me if I'm wrong here. I don't remember what I'm writing. Right. What's the next?
No, for the that's negative.
Okay, thank you. What's next? +4? And what's the last one? Okay, thank you. And what I'm going to do is I'll plug in 0. Now, this is the first and last time I want you guys to ever do that because it's really common sense. But once again, we like to have this on our notes. Everything that has a 0 is going to what?
0.
It's going to go away. All those are gone. So what am I left with? So really in the future, all you need to do is you need to look at the very last number that doesn't have an x on it. Okay? Now, we're going to look at a problem later today where they all have x's. So what would your y-intercept be?
0.
Okay, so you guys got it? So you don't need to write all this out. Once again, you can tell just by looking. The y-intercept is 0. I'm sorry, 6, not 0, 6. I misspoke. The y-intercept is 6. Yeah. All right, last thing. Now for this well, the graph is the last thing, but we're looking for one more thing to get a good graph. And the last thing we want to know is what's our end behavior? End behavior. That's from Friday. So if you need to, go ahead and get out your notes from last Friday, 6.5. I'll wait for you for a second if you want to get those. Now, when you're trying to find end behavior, which term do you look at?
The first.
The first term, or probably a better way of saying it is the one with the biggest power. Is this my first term? Okay, so notice that the power is even, and my coefficient is negative. What do the arrows look like on the, which way is the arrow pointing on the left, up or down? Down. Which way is the arrow pointing on the right? Are you guys looking at your chart? It's down on the left and on the right. Remember, when it's an even power, they both go down or they both go up. The odd one goes in opposite directions. So you got to look at that chart. It's hard to remember it. All right. Anyway, we've looked at all the things we can. Once again, I'm making this seem hard, but like I said, these things are all pretty quickly identifiable. And so we found enough pieces, I think, now to where this should be able to help you graph any polynomial. You can look at all these pieces. So let's go ahead and do it. The first piece we found, you guys, was the roots. So let's go ahead and graph our roots. My roots were -3? -2 and then +2, right? Okay. Now, something else I'm going to do, which you don't have to do this, but for note's sake, I'm going to do it. I'm going to label which one's the bounce and which one's the through. Which one was a bounce?
2. No, wait, 3.
This guy was the bounce. Okay. These guys are through. So I'm just going to put B and T to remind myself of that. After I found my roots and the bounce points, I then found a y-intercept. What was my y-intercept?
6.
Okay, so let's put a dot there. And then the last thing I found was my end behavior. I had arrows going down on the left and on the right. So something like that and something like that. We have enough information now to connect all these dots and lines to get a pretty decent picture of what this polynomial would look like. So I'm going to start here on the left at the end of my arrow. I'm going to go up, and what am I going to do when I get here? We're going to bounce. So it's going to bounce down, but then I got to come back up, right, to go through that root. And then I'm going to go until I get to there, and then I'm going to come back down, and what am I going to do here? Go through and then connect the dots. That's your graph. So we bounced at -3, we went through -2 and 2, we touched our y-intercept, and my end behavior is good. That's a good question. We don't know that. So Josh asked a good question. He said, how far down do you go? We're not going to look at that. Because he's right. It could have went like this. We really don't know. It doesn't matter because we're not going to be that precise, but you could get more precise. I'm not going to make you do this, but you could plug in like -2.5 and find out what the y value is, and you could figure out how far down it went. But we're not.
When we're doing this, it doesn't matter how far down we go.
No. So long as your roots are good, your y-intercept and end behavior is good, you've got a good enough graph. So, all right. So I'm going to do a guided practice with you. That means I want you guys to do everything step by step here. Now, how much of this you guys choose to write is up to you. I don't mind if you try to do this super quick or not. Oh, I don't want to write that yet. I want to write the original function first. Where is it? It's this. Okay. So step 1 is factoring, right? But I told you I was going to do that for you today. So here's the factored form. Okay, step 2. I want you guys to go ahead and do step 2. I'll give you 30 seconds. Oh, where'd it go? Go ahead, Austin.
2 and 81.
Good. There's one more, though. And it's because this one's a little bit different than what I did. Remember how I ignored my 1/6?
3x minus. Oh.
You got to give this guy some attention, right? So you're going to do this one too. And so what will that give me? Okay. So we have 3 roots here. 0, 2, and -1. All right. Go ahead and move on to your third step, please. And unless, does anybody have a question about 2?
The third step is like even off.
Yeah, the multiplicity, yeah. So, CC, what's the multiplicity here for 0?
1.
Good. How about for 2? And how about for -1?
1.
Okay. And then so CC, we want to know is it bounce or through for this one?
B.
So it goes through the x-axis at 0. It bounces off the x-axis at 2, and it will go through the x-axis at -1. All right, now I want you guys to do the fifth step. Go ahead. That's right. Y-intercept is 0, so they all have x's in the beginning, right? So if you plug in 0, you're just going to get 0. So now what that means is my y-intercept is my root. The x-axis is touching the x-axis and y-axis at the same time. All right, now we're going to do number 6, end behavior. I'll give you a minute for that. Find your end behavior. All right, so I'm going to ask Ms. Patterson, what's going on the left side of my graph? Is it going down or up? Okay, how about on the right side? So what I regret about this problem is it's the same as the last one. They're not always like that, though, so you got to look at that chart, okay? All right, so now let's go ahead and graph it. So this is where things get interesting. So I'll kind of walk you guys through it, but we're ready to graph it. So start by putting your roots on your x-axis there. And then you want to label those roots with, you don't have to do this, you know, but I'm going to say what you want to think about this at least, whether it's a bounce or a through at this point. So I labeled it with B and T. You don't have to label it if you don't want to, but make sure you're aware of where it bounces and where it doesn't. And then plot your y-intercept. Now your y-intercept it should already be plotted because your y-intercept is a root. So that's kind of a weird one, but it happens sometimes. Last thing you guys want to do is you want to put that end behavior on there. Draw those 2 arrows going down on the right and left side of your graph, and then see if you can connect all the dots with the arrows, being careful to bounce where you're supposed to bounce, going through where you're supposed to go through. It doesn't matter how big the humps are now. Here we go. We should have had a root at 2, right? At -1 and at 0. And 2, was 2 the bounce?
Yeah.
Okay, my y-intercept is already there, so I don't need to plot that. My end behavior is the same as it was last time. So I'm going to start on the left. I'm going to go up and through, bounce, connect. All right. And that's it. So so that's a guided practice. So I'd like you guys to try one now from beginning to end all on your own. And then that'll conclude our lesson. Yeah. Okay. So let me give you guys a student practice here. And let's see. So here's your guys' polynomial. X to the 5th plus 2x to the 4th minus 2x to the 3rd minus 4x squared plus x plus 2 equals y. The factored form, I said I was going to do that for you today. It looks like this. So there's the factored form, and I'm going to let you guys take it from there. Go ahead and graph that. Yeah. So I just want to show you guys how quick this can be once you have the idea, right? So you're going to make a graph. The first thing I'll do is I'll put all my roots. So +1, -1, -2. You got to change the signs. These are even powers, so those are both bounces. The ones are both bounces. My y-intercept is 2. My end behavior is up on the right, down on the left. Which means we're going to look like this. Through, bounce, bounce, connect. I missed my arrow, but you guys got the idea. All right.
I got that.